Great to be here. This is our first time at, I'm going to close this door because this is our first time out here at Connected Data London, and we are very excited to be here. I'm joined by my colleague Thomas Cook, and what we are seeing quite a bit of traction. We're seeing a 100% growth rate in top line. And what we want to talk about in this is really talk about some of the use cases and why people are adopting graph, and really also get into some of the myths in terms of some of the resistance which we saw in the past, which we now no longer see. So with that, just want to give quick background from where we are going to be coming from. We are with Cambridge Semantics. We have two core offices in Boston and San Diego, though Thomas is in Austin, and we have people all over US, and increasingly we are seeing a strong demand not only in Europe but also in Asia, and we've got now a number of customers in Europe. The foundation of our team is two core technology groups, a team that came out of IBM's Advanced Internet Group, and another team which were the founders and the technology people behind Netezza. They built Netezza and then sold it to IBM, and then after that they did PowerXL, and that's the underlying technology behind Redshift. So people who can really deal with scale and speed and enterprise grade performance. And we've got two products. So the original product which we started off with was Anzo, which is still our core product, which is a data management, data fabric product, which can bring in information from diverse sources, create knowledge graphs, allow for interactive data discovery, and then allow for self-serve analytics. And as a part of that scaling, Anzo Graph was the database supporting that in terms of scale. And then last year we spun out Anzo Graph as a standalone graph analytics database. So super fast, highly scalable, award-winning database, and this talk is much more geared towards Anzo Graph versus Anzo. So if you want to learn more about Anzo, we do have a booth, and we would be happy to walk you through what we're doing with Anzo. But here we're talking much more from a graph database perspective. So the types of use cases which we are seeing, really, when I went back and looked at all the different use cases which you're doing, I said, what would the buckets be? And there are four buckets. It's the data harmonization, data understanding base, the unification side. It's then from there, then data discovery kinds of use cases, data analytics, and then processes. And one of the key processes where we are seeing a lot of people make deployments is in the compliance and regulatory side, where they're using a graph piece there. And from the graph database perspective, what we're really seeing is really being able to provide scale and just a packaged environment for being able to do analytics, a variety of different analytics pieces. The interesting piece which we saw is that a few years back, people started looking at knowledge graphs. And we were one of the first companies in graph to really start pushing the enterprise knowledge graph concept, especially in pharma is where we started doing that, in financial services. And that kind of use case is much more about having common business understanding of data. So if you look back at traditional relational systems, the schema and the data model was understandable by IT and understandable by machines, but not really business friendly and understandable by businesses. The knowledge graph, one of the key reasons where people are saying is that I'm going to have all this diverse data. If I have to always go back to IT and they have to create the model, then it's a much more slower process, and there'll be a whole bunch of reasons why I don't want to go back to IT, and I say, let's not just do it. So knowledge graph, what we started seeing, that people started saying, I want to have a common business understanding, a canonical model, so that I know what data lies where, and I want linkages to the different data sources, and I can bring information in and give self-service for discovery and understanding, and also starting to move towards doing self-service analytics. But today, where the use case which I want to focus in before I hand it over to Thomas to talk about myths and other items is really on the data analytics side, which is a key growth area. So as data continues to grow, people are really saying, yep, I can do manual data discovery, I can do manual data analytics and things like that, but I really want that machine insight. Because that's what's going to be more valuable. So if I have growing amounts of data, and especially with the pace at which unstructured data is growing, how can I get insights, machine-based insights, which can make recommendations or which can give me a key opinion leader, some thought there, and use that for my analytics. So this bottom-up way of doing it versus the top-down knowledge graph way is what we are seeing a lot of traction there, and that's where people are starting to use graph databases there. So I want to drill down on that use case. We've got a customer and partner in a company called Parable AI. Parable AI is a cognitive analytics platform, and one of the solutions or the use case which they built is dealing with for fund managers, so equity analysts, equity fund managers, and what's happening on a key growth area for the fund managers is in the socially responsible investing. So a lot of funds are going towards socially responsible investing, and fund managers are getting that funding for doing that. And unlike traditional investing approaches where you looked at, say, from a database or looked at data from Bloomberg and things like that, here you have to look at data not only from databases, which you'll get, but also data from news articles, from regulatory filings, and a whole bunch of variety of sources. So for a fund manager to go all of that, there's not enough time and day in the world to really be able to get all those access and find out, like, okay, if ExxonMobil, what did they do in coal liquefaction or coal processing plants? Are there some issues they faced in a particular area? Was there a news article that showed up in Asia relating to ExxonMobil activity? So that kind of data impact is very important for a fund manager who is investing in socially responsible investing area. So what Parable does, Parable has core technology in natural language processing and text processing and plus machine learning capability. Right? They created this solution leveraging our ANSOGraph database, which can go out and extract entities and relationships and facts from different sources, create a cognitive model, which is really a knowledge graph, based on what the fund manager has defined as the parameters important to them. And that cognitive model then can pull entities and facts which the fund manager is interested in into these reports and documents, and with all the provenance and data lineage. So if you want to say ExxonMobil and it pulls out a fact and saying Exxonmobil, here's a spill happened in India, you can go right to the article and you can see where it came from, what was the source, and you can do that not only by time based but a whole different set of criteria. So that's a practical application of how it's improving the life of a fund manager and analyst. And those are the kinds of solutions which people are doing, and that's what's getting much more rapid traction and adoption there. So the piece where Parable already had technology is on the NLP side and tech side, where they leveraged ANSOGraph and our graph database. It's really for scale, speed, and also for analytics capabilities. So that together is where the whole value proposition come in. And here's from their perspective, if you could talk to Rajiv, the CEO there, one of the things which I had him outline as to why us? Why are you selecting a graph database? There's so many different graph databases, and a number of them claim to be scalable piece. And one of the things which we do, a side thing, one of the things is that we do need more benchmarking across those different databases, so people have a much better idea. We do feel that we have one of the fastest and most scalable database. But the four criteria which Parable looked at was A, we are native graph. which is very important for them. They're extracting information from different sources, and they're using RDF, and especially with unstructured information, having a basic graph kind of infrastructure is important because it's flexible, as you can easily add different data types and different data sources to that. Second, the blending of analytics with graph, so that you can do really quick analytics. So, from a user perspective, one of the themes which we have in Cambridge Semantics is that you should not have more than sub 3-second responses. If you have more than 3-second response, then people are going to walk away from their terminal. So whatever you need, whatever application, whatever piece which you build needs to have sub 3-second response. So the ability to being able to do analytics right within that database was an important item. And ability to scale, linearly scale. So that's a very important capability, right? Is that you can start small. You can start with a single server, small database. And as your data needs expands, or as you want more performance, you can add more servers. And the system will get faster, can handle more data. And that's very important from a business perspective, because even from a customer perspective, they don't want to size up for a much larger server or a much larger environment. They want to spend small, prove it, and then as their customers and their value grows, then they want to be able to add. So again, from a Parable and Parable's customer perspective, that was an important element. And then the other piece was, RDF was great for understanding the data, describing the data. But you want to be able to have other attributes. You want to have weights. And that's why label property graph took off. So one of the things which we've pushed on the standards group, is really, and we took where what Neptune and Blaze Graph started initially doing, is saying, how can you have label properties with RDF? So keep all the value that RDF has, and which has all the description and elements to it, but get all the other values of the label properties. So we started using RDF star and Sparkle star, the label properties on top of RDF. It's important to understand, especially if you look at different groups, there are vertical groups which have used RDF to create vertical data models. So in healthcare, you have HL7 Fire, which is using standards based on RDF. In pharma, you have CDISC, which is based on RDF models. In financial services, you have FIBO. And those are, and some of those are getting mandated by government to be used from a data exchange perspective. So CDISC is the standard which FDA is mandating that pharma companies use. So having ability to be able to do analytics with that kind of data is something which we thought important. But the other side of it, we looked at saying that, there is a broad adoption of Neo4j and other standards. And at the end, it shouldn't matter what you want, what language do you use. So we are going to be supporting Open Seifer. We made an announcement on that, and that will be coming soon. So right on the same database, you can bring in RDF, you can bring in Open Seifer and the other side. And then, as we are saying, that shouldn't be the only languages. There'll be other languages which you should be able to access and get information from, like Python. Increasingly, as machine learning, that's an area where there's a lot of growth happening. So again, what we are saying is that the whole area of getting into these, whether war fights or whether you should use RDF or Seifer or Gremlin, we should get away from that. From a business perspective, looking at what problem are you really solving. So these were the 4 reasons which, from a Parable and Parable's customer perspective, why they selected us. And what we're really focused on is going to market, helping drive things. And there are definitely myths and things like that, which Thomas will now talk about.
Yeah. Thanks for coming today, guys. My name is Thomas Cook, and I will talk with you about a couple of different myths around graph databases. And I'm just curious, show of hands, how many of you are familiar with RDF? I know you've heard about it a lot today, but how many of you are familiar? And how many of you are familiar with RDF star? Okay, so yeah, just a few less. And so, well, So one of the first myths that I want to talk about is really around the performance of graph. I mean, graph databases were considered niche in the past because they don't scale or they don't perform well, and so on small data sets and that type of thing is typically where they were used. And then you also have the breakdown between what is your workload type? Is it OLTP where you're running a lot of transactions, or is it OLAP where you're doing more analytical style processing? And so we are a massively scalable graph database. We have broken the we've done the trillion triple benchmark. That was over 200 nodes on Amazon Web Services. We published a number of different benchmarks here. As Alok said, we think that we're one of the fastest graph databases on the market. And the first benchmark I'll mention here is the Lehigh University benchmark. This is a data load benchmark, and we were 113 times faster than the previous benchmark that was published on that. The TPCH is a data warehouse style workload. TPC is a database workload, is a database standard for benchmarking. It's used across industries. Oracle, Teradata, all these use it. Well, we converted that to Sparkle, and we converted it to CSV, and we loaded it, and we did the same thing on one of the major leading graph databases, and we saw 217 times performance improvement over that database. We did the same thing on Spark SQL, and we saw anywhere from 10 to 30 times faster on Spark SQL. And then we also published some Graph 500 benchmarks, as well as some graph algorithms, weakly connected components against some of the other vendors that you can see there. So that myth is basically busted. There are no longer niche databases. We're doing massive scale, massive volumes, and we're linearly scalable too. In this benchmark, for the TPCH, we did it against a single node, against the major leading database, OLTP database, because they could only run on a single node. But we also did it on 40 nodes, and we saw linear scalability. So we scaled up the data by 40x, and we scaled up the number of nodes by 40x, and we saw almost the exact same performance across that. So what that means is if you add 40 nodes and you have the same amount of data, your queries will run 40 times faster. But as your data grows or your performance need grows, you simply add more servers. Yeah?
Are you any questions?
Sure, I'll take a question.
Is that, so you're saying if you're adding more nodes, your queries will become faster, but is that necessarily true if the queries are not parallel in each other?
There are some, so in that benchmark, you can actually see there's a graph there that shows you some of the queries spike because of the type of query that it is. It is not, there are certain type of queries that force the data onto a single node. But across those 22 queries, the majority of them they run at almost the exact same time. So encourage you to download that benchmark and take a look. But yeah, good point. There are certain queries that do spike like that. Mm-hmm. Yeah. So not only, we're also deployable across all cloud environments. So we use Kubernetes and Helm operators, and we can spin up a cluster of as many nodes as you need and automatically load data and run workloads across those. So this can really save you in infrastructure costs if you don't need a database up 24 hours a day, 7 days a week. Maybe you just need to do weekend or month-end processing. You can use Kubernetes to spin up the cluster, load your data, perform the analysis, and then bring that cluster back down and greatly save on the infrastructure costs. We can also deploy on bare metal. If you want to run it in your own firewall, on your own servers, we can give you Red Hat or CentOS tarball to install it from. So myth number 2 that I was leading into is here around labeled property graphs. You have to choose between labeled property graphs and RDF. And we've heard a lot about this today in some of the different sessions that I've sat in. So really, the decision is, will you choose an RDF triple store or will you choose a labeled property graph? And here are the differences and the similarities between those. And that's a myth. Because today we have RDF Star, which is a new standard. It's in the standards body at the W3C now, so it will become a standard very soon. But what this allows you to do is basically add properties to the edges. So this is one of the main differences between RDF and labeled property graphs. And here's a very simple graph I'll just walk you through to explain this concept. So here we have Jack, a person, and Jill, a person. They're friends, and they both went up the hill. Okay, each one of these nodes or entities has properties associated with it. So Jack is a man, he has a birth date. Jill is a woman, she has a birth date, and the hill has some properties associated with it as well. RDF Star adds these blue boxes here, which are the ability to add the properties directly onto the edges. So now I can say on the friend of edge, I can say where they met at. They met at the hill, and the date, the met date. The same thing, the went up edge, the property there is the date they went up the hill, and etc. So this is all now with RDF Star, we can express the same data that you can in a labeled property graph in RDF. We're also planning to support Open Seifer, as Alok mentioned. So the data is it's an RDF triple store, but yet the query language, we can now, because we support labeled property graphs, we can now support Open Seifer as well. So you can, those of you that know Open Seifer and are familiar with that language, will soon be able to use that to access the data that's stored in AnzoGraph. So myth number 3 is that analytics is synonymous with graph algorithms. And so while graph algorithms are very important, there's a lot of other types of analytics or analysis that you may want to do, which is important for data that's stored in your graph. So if you take all of your data from a relational database, you want to be able to do a lot of the types of queries that you can do in a relational database, such as aggregates or windowed aggregates, advanced grouping, cubing, these types of things. We have all the different graph algorithms. We also support inferencing, so the ability to create additional triples in your database based upon rules. That's an important feature. A number of different database extras here that I've mentioned: name views, name queries, advanced grouping sets like cubing and roll-ups. These are important if you want to look at all of your data and do analysis across all your data. A lot of these come with Sparkle, but we've added a number of different extensions to Sparkle as well to do the cubing and roll-ups and these type of things, windowed aggregates. We also have a number of different data science extensions. So these are available today, and you can also write your own. So there's hundreds of functions that come inside AnzoGraph. Some of those are part of the Sparkle standard, some of those are extensions that we've added. But if there's a function that is not available there, you can easily write your own in either C++ or any JVM-based language, Java, Scala, etc. And then we provide a mechanism for you to call those functions through the Sparkle query language. So you can call them as functions or Sparkle endpoints or table functions, that type of thing. So the language is, the platform is highly extensible with that feature. So as the data becomes more and more diverse, we're really wanting to see analytics across all of those. And I have a quick demo here that I'll show you where we're pulling in data from several different sources. This is very common with our Anzo product as well. So the knowledge graph, we're building knowledge graphs for some of the largest pharma and health and life science and financial services companies. They have diverse data from all over an organization. They want to pull that all into a single place. And we can do that in AnzoGraph as well. The data sizes are growing exponential rates. We want to pull in all these different diverse data sets and do analysis across all of those for single view. And traditional ways that that's been done, taking structured and unstructured data, there's different approaches that we've used over time. So enterprise data warehouses, Hadoop, Spark, these all approaches have been used. From a data warehouse perspective, it's very rigid and brittle data model. Anytime there's a change, It's very costly because you have to redesign your data model and build new ETL and reporting and that type of thing. It takes a long time to build. The EDW projects can take many years to design and build and millions of dollars to set up. Hadoop, we've seen many projects fail. A lot of the major vendors are failing. So Hadoop has not been the answer to create this canonical model and look at data all across the organization. It's good for certain use cases and certain workloads, but for what we're talking about is doing enterprise-wide analytics. This is not a good solution. And the same thing with Spark. Anecdotal evidence suggests that as people are building these data pipelines in Spark, you give two data scientists the same problem, and they'll come back with two different answers a lot of times because the pipelines are complex and they don't always know how to pull that data through from the source systems with the same rules and mechanisms. And with the graph database, you can track all that lineage, you can create automated processes and see that a lot easier. And so here's a view of pulling all that diverse data, and you can see the different colors there as that's pulled together. So a quick demo. I think we still have a few more minutes. Actually, no, we may be running out of time. Let me know when we need to stop.
It's the break, so we're just going to go.
Okay, how now? Okay, great. So we have a flight delay demo where we've downloaded some public flight delay information. This is the website that comes from. It basically downloads in a CSV file, and here are the different columns that you can see here. So this is what the CSV file. Each one of these is a record of flights from 2003 to 2016. You can see all the different columns that come in there: year, month, day, flight number, tail number, origin airport, destination airport, and then a lot of other information about the delays, what type of delay it was, how long it was, etc. So how do we take that and create a graph model from that? And what we do is we start creating triples, or basically facts from that data. And so each one of the nodes here represents a type. The relationship between those, the edge between those is the relationship. So an airport has a departure, it's a flight. Airports have arrivals, those are also flights. And when a flight goes from one airport to the other one, we can connect those with the destination link. Now there's lots of different ways to model your data, but this is just a simple way. It really depends on what type of analysis you're going to do. So this may be the start of your data model. Once you have the data in this format, as I mentioned, the flight is the type, and then these are the different properties we saw from the CSV file. Here's instance data. So we have airport code Boston is connected to airport code JFK, and then we have an edge property at distance 187. Once we have all these diverse data, we can now start to do different analysis on that. Or actually, now I can pull, so this demo, I'm running short on time, but we've pulled in data from multiple different sources now, and we can create a combined. So each one of these colors comes in from a different data source. And I can give you guys we have a free download, 60-day trial. If you'd like to try AnzoGraph, I encourage you to do that. You can install it on the cloud or on with Docker. You can install on Red Hat as well. But I can give you these in Zeppelin notebooks so you can run these examples yourself. The data is on S3 buckets, so you simply run the queries. It pulls the data in, but you'll see it pulls in aircraft registration from the FAA, airline information, the census data for city, state, population, etc. Now we can start doing different BI-style analytics and different graph algorithms that we can run on those. So we can look at the longest flight segments by distance from Boston, airports less than 400 miles from Boston. A number of different queries that we can do there, and then the different graph algorithms are supported too. So let me just switch gears here, and I know we're running into the break, and I want to save a few minutes for questions. But this was not my computer, so bear with me while I pull up. Okay. Sorry, I thought this machine was on the internet. All right, well, I'm not exactly sure. I don't see the Wi-Fi names listed here, and this is not my machine. So I'm happy to show you this demo at our booth, or if you like, please come by and we can scan your badge. I can contact you. We can set up a meeting. I'm happy to give you this demo personally and answer any questions that you might have. So thank you guys. Appreciate you coming by and happy to take any questions. There must be cookies out there. That's what it is. Well, thank you guys. Appreciate you coming.